Hi everybody. I'm sorry I'm not in class this week. This is also my first attempt at using my iPad to make you a video, so sorry if it's going to be a little bit of a rocky road here. Before I get started, really, I want you guys to try and do the bell work on your own, but I'll give you a little bit of an intro as I would if I were in class. So the question here just says a clothing store offers a weekly salary of $400 plus 3.5% commission on the value of sales. What that means is you get paid $400 if you sell nothing, but if you sell stuff, you get 3.5% of its value back added to your $400. The first part of this question wants you to remember the 4 different representations for a line that you learned last year. So I've given you a description. Okay, so that's one of them. It's probably pretty obvious that another one is a graph since I gave you a grid. And then there's 2 other ways you could represent the situation. So what I want you to do is go think about that. And then if you can determine an employee's earnings if they sold $5,000 in clothing last week. Okay, so go do that. Pause your video for a few minutes. And then I will, or I guess restart the video, and then you can listen to me kind of run through it. Okay, so like I said, graph is an option. In this case, the graph is going to be the one that's kind of the worst, but that's okay. So the other options would have been a table, which is the one you guys usually forget because you don't really love making them, and an equation, which you probably remembered even if you didn't remember how to make it. So that's the plan here. We need to do those things. Remember, you have to convert percents to decimals. So 3.5%. You would just divide it by 100% to make it into a decimal. Okay, so your equation would look something like y equals $400 plus 0.035 times the value of what you sell. So x is going to be the value of sales, and y would be your total earnings. I'm going to talk to you a lot about defining your variables. This is what I mean. Always tell me what x and y represent. In a table format, you'd have like x, y. At 0, you make $400. I would count up by something pretty big over here, so like 1,000, because that's still only going to get you $35. Okay, so every $1,000 you sell, you get $435 now, and then at 2,000, you get $470. Remember, it's linear, so you can kind of keep going. So we can actually answer question 2 if we just continue this table. Right, I'm just going to keep adding 35. At 4,000, I'm at 540, and at 5,000, I would be at 575. Okay, and then that actually answers this part of the question for us. So we don't have to necessarily use the equation. You could. Okay, so that was the solution, plus it gives me a table and an equation. The graph isn't great here because the numbers are kind of wonky. But we can just remember where you put things. So your x goes across the bottom. So this bottom part should be value of sales. And then up the side, you should have earnings. Okay, so 0. If you want to, you can use a break in your graph. I'm just going to kind of spread it out and hope for the best here. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to call 8 is about 400, and then 8 more will be 500. Okay, and then this is 550. And then I'll spread out across the bottom too. Like I said, this is not the greatest way to graph, or the greatest set of data to graph, I guess. It's not the actual graphing that's the problem, it's the numbers. Okay, so at 1,000, well, at 0, we know we're at 400. At 1,000, we know we're at 435. 4 would be 20, 12, 50, 25. So like here. And again, don't stress too much about the graph. The idea was just to remember that you can graph to represent this stuff. And then you connect your dots as best you can and make yourself a pretty picture. So hopefully those representations are familiar to you. You learned a rule of 4 in grade 9. You have a description, a table, an equation, and a graph for any linear relationship, and really any relationship that you're graphing or that you're working with. Okay, a lot of the rest of what we're doing today is review. The only thing that's tricky is we're going to talk about creating equations from words, which I know is a struggle, but just keep practicing and it'll come. Okay, so this stuff we've talked about already. First differences for a linear relationship are equal. So if I give you a table, you just check the first differences. An equation can be written in standard form, which we don't love that much, or slope y-intercept form, which we do like a lot because it tells us a lot. The graph of a linear relation is always a line. Please remember, it's always going to be a straight line. A line with a positive slope rises to the right. Okay, so it's going to look like that on your graph. And then a line with a negative slope falls to the right. So it looks like that. Okay? Slope of a horizontal line is 0, and the slope of a vertical line is undefined. So those are things that we've already discussed in this class with me, present. So that is good news for you. Okay, most of what you're doing for the next few days is review, so you'll be okay. All right, so practice problems. If I give you a table and say show that this thing is linear, I want you to use first differences. Okay, so you're going to look at these. The order matters, so think about what's happening when you look at it. I'm looking at my y values are decreasing by 3. That means I need my first differences to be negative because my slope needs to be negative. Okay, so when you're taking those first differences, please make sure that you're subtracting the higher number in the table from the one below it. Right, so 0 minus 3 is what we want there, because that whole thing is decreasing by 3, and you can see that if you just look at the pattern in the table. We've done rearranging our equations, so if we have 2x minus 5y plus 3 equals 0, you know you want y by itself. Because it's negative, I would probably move it to the other side. Okay, so 2x plus 3 equals 5y, and divide by 5 everywhere. We get 2/5 x plus 3/5 equals y. And if you want it to be written y equals mx plus b, just flip it around. No big deal. Okay. And then underneath, there's some vocabulary from grade 9 that you may or may not remember. Don't stress too much about it because it's not something I spend a lot of time on, but it does ask you if it's direct or partial variation. Direct variation means passes through 0, 0. Okay? So that first one is your example of direct variation because it goes through the origin of your graph. The second one, because it has a y-intercept that is not 0, that makes it partial variation. Okay, so just the fact that it has a y-intercept that isn't 0 tells you that it's partial variation. Okay, so now the stuff you might not want to do. Writing equations from words. Remember, you're going to assign variables before you write an equation. Define those variables, tell me what they represent. Don't let x equal a number. Don't tell me x equals 4. You want x to equal like the number of kilometers driven or something. Once you've assigned the appropriate number of variables, we're usually going to have 2. You guys have to watch for words that tell you what operations to use. So total, add, difference, subtract, product, multiply. Once you write your equation, please, please, please see if it makes sense. So either replace your variables with the words you use to define them and see if it makes like logical sense to you, or put in a number and see if you get an answer that would make any sense in real life. If you're getting negatives and you're trying to figure out like how many, I don't know, lawns you have to cut, obviously something's wrong with your equation. So try something else. Be persistent. You all can do this, but you have to practice it to be able to do it. Okay, so pause for a second again. Take a minute with these examples and see if you can create equations. The only thing I'll remind you of beforehand is the value of a nickel is 5 cents or $0.05, and the value of a dime is 10 cents or $0.1. Okay, so pause, take a minute, see if you can define variables and make equations for those two situations, and then start the video again so that you can see the answers. Okay, so we have a vending machine that has 5.75 made up of nickels and dimes. write an equation to model the total amount of money. So that's telling me what this equation has to model. I also know that I know the total amount of money. So whatever I'm going to do is going to need to be equal to 575. Okay? Think about what you don't know. Okay, so the things that we don't know are, I don't know why my pen is so thick right now. Hold on, let me thin that out a little. Okay, what we don't know here is like the number of nickels that we have and the number of dimes that we have. Okay, so when you think about defining your variables, X would be number of nickels, Y could be number of dimes. If you used N and D, that's fine, or you did it in a different order, it's okay. Okay, so, but I need to figure out the value that I have of each, right? So the number of nickels is X, but I'd have to multiply it by its value to get to that 575, and then same with the dimes. Okay, so this would be my equation. So 0.05x plus 0.1y equals 575. The second example might be more familiar to you guys. We seem to do a lot of these in grade 9 because it's a straight like y equals mx plus b equation. So what they're telling you there is it's $35 a day and then 35 cents per kilometer that you drive. And they want an equation for a daily cost, so that means 1 day, right? So one of the things that I don't know is the daily cost, right? And the cost that it is per day is going to depend on how far I drive. Oh, sorry, I meant to use a, let's just use the highlighter. There we go. Okay, so X is going to be number of kilometers that I drive. Okay, so the number of kilometers that I drive is going to determine how much I pay for the day. And then I know that Y equals $35 plus 0.35 times X. Okay, so again, read it in words and be like, okay, the total daily cost is $35 plus 35 cents times the number of kilometers that I drive. Yep, that makes sense. If you multiply 35 times X, it's going to be a really expensive car rental. Uh-oh, I'm writing and I don't mean to be. See, I told you it might be an adventure, guys. There we go. No pen, just scroll. Okay. And then odds and ends is, again, stuff that we've talked about already in this exact class. So if we want to figure out if an ordered pair satisfies or is a solution to a linear equation, we plug it in. Okay, so for number 1 here, we would let x equal -1 and y equal 3 and see if it works. Okay, so 2 times 3, does that equal 10 plus 4 times -1? And I think I can pretty confidently say that 6 equals 10 minus 4, so yes. So that means the point -1, 3 is on the line. So if I graphed that line, well, -1 and 3 would be on it. And then the second one, again, we do the exact same thing. So I'm going to have 2 times 5 equals 10 plus 4 times 2, and you should immediately be like, I feel not great about that because you get 10 equals 10. Oh no, I don't even know what just happened. There we go. Oh, and everything is gone. How'd I do that? Okay. Okay, so we get 10 equals 10 plus 8. And hopefully you guys are like, oh, that doesn't make sense. So that point is just not on the line. Okay. I will quickly put this back in. And try not to press whatever I just pressed. Okay, so one of those points is on the line, the other one is not. The next example is asking you to write an equation of a line. We've done that too. Okay, so again, this is all just nice review of things that we did last week. So write an equation for a line with a slope of -3 that passes through the point -2 and 5. Remember, we start from y equals mx plus b, x equals -2, y equals 5. So 5 equals -3 times -2 plus b. 5 equals 6 plus b. We're going to subtract 6. -1 is b. And then y equals -3x minus 1. Okay, so that again we talked about last week at some good length, so hopefully that is familiar. And then the last thing that we haven't done a ton of, once you guys have written an equation that has two unknowns in it, you guys can solve it, right? Just make sure you plug in for the right variable. So if we had 30 dimes in that vending machine from question 1, how many nickels were there, right? So we know that we had 0.05x plus 0.01y equals 575. And then we just have to pay attention to make sure we plug into the right spot. So the y was number of dimes. So 30 goes in for y, which just means pretty much that I had $3. I had $3 in dimes, right? So, and again, it's okay to think about things in real life. So 0.05x plus 3 going to be 575. So pretty much what the question is asking you is to figure out how many nickels there are in $2.75, right? Because we would subtract 3 from both sides and then divide by 0.05 and end up with 55. Please, at the end of a word problem, write down, therefore there are 55 nickels. Okay? So hopefully most of that feels like review for you guys. You're now working in your textbook. It's not like optional work. You need to do those textbook questions that are assigned today. Please go and do that now. Get them done in class. Have no homework. And I'll be back with more videos for you tomorrow.